Okay, so this is question 3 of the examples that I gave you.
Yep.
Oh shit, the 6 pole. What else was given?
Frequency of 50
Yeah,
is a star.
yeah.
ZS, which is equals to 0.05 plus J 0.25 per unit.
Okay. And then we have to calculate all that other stuff.
So it's connected to an infinity bus.
Yeah.
And then the power factor, it's lagging, which is 0.8. Lagging power factor of 0.8.
Okay.
Then now you have to compute, which is calculate.
Yeah.
You calculate the developed power.
Yeah. All right. So first of all, you have to calculate E. That'll be 1 angle 0 plus 1 angle minus 36,87 times 0,05 plus J 0,25. That gives us
Should we give you the answer? Okay.
Oh yeah, you can if you've got it.
1.202.
Let me just fix this thing to 0.919.
1 point.
Huh?
That's one.
Oh, sorry, plus 1.88.
I don't know, what did you do? Oh, maybe it's because of we already changed the ZS. We didn't put it the way it is.
Doesn't matter.
So, but it's the same thing. Yeah.
No, sir, I put it the way it is. I didn't get that.
1.202.
Like, I got 1,202.
All right, let
Same
me
as me.
one in the yeah. 1.202, make it 3, at an angle of 8,16. Right,
Yes.
so the developed
Yes.
power is going to be E over Z. What is it, first one?
It's E.
E.
E over Z, E cos beta,
Yes.
minus V cos beta minus delta.
Beta plus.
Yeah, okay. All right, so what is the beta angle?
It's 90.
78.69.
Okay, cos 78.7
78.
is close enough. Minus
Yeah.
1 cos of angle 75 or 78, so that'll be 100 and something.
Plus your 8.131.
How much?
It's going to be 8 plus 78. So
Yeah,
78.69 plus 8.131. It's 86.821.
86
86.
to 1. Okay, and the value of Z?
0,8496.
The value.
Oh, the value of Z
0.8.
is 0,255.
0.26, yeah.
All right, so then you can calculate developed power.
Yes.
All right.
0.85 per
How
unit.
much?
0.85 per unit.
Okay. Next question then.
Sir, can I ask something?
Mm,
Like, to be on a safe side, how many decimals should we write?
3.
Like after a comma? 3.
Yeah.
Okay. Like from beginning, your beta, your angles, everything.
Your angle can be 2 or even 1 if you round it off, because that doesn't make a big difference.
Okay, but the value like Z, we must write 3 decimal.
Yeah. And your final answer
Voltage
as well.
is
0.85.
okay. Thank you. Sure.
What is the power now? 0.85?
2.55 mega
No.
watt.
Your power 0.85.
Per unit.
Yeah. Okay. All right. Then the next question.
Oh, the next question, it says, for the same output power, the induced EMF is increased by 15%.
Okay.
Now you have to determine.
The load angle.
Okay, I must wait.
Yeah.
Yes.
So now.
So now you must determine the new current and power factor.
Yeah. So now it will be E2 over Z, E cos beta, sorry, minus V cos beta plus delta. Let's call that delta 2, no? That must be equal to E1 over Z, all right, yeah, this is E2 now. E1 cos beta minus V cos beta plus delta 1. And then you have to make delta 2 the subject of that formula.
Sir, can I ask you something before
Yeah.
you move forward? Yes, sir. Isn't it supposed to be V2 over Z instead of E2, because now we're dealing with other output power?
I wanted to say that.
Okay, yeah.
We are not using the developed
The
one.
developed power. Okay, so
Yes,
it's V.
scratch that out.
No. It's V over Z.
And again, sir, and on your formula as well, it's supposed to be V over Z into E1 cos into B minus gamma 1 minus V cos B, instead of you doing it the way that you did.
Like so.
So,
Yes.
you need to fix the formula. Yeah, it's correct now. That is why I was saying scratch the top part.
Yeah, it is correct. All right, so V over Z, E1 cos beta minus delta minus V cos beta. And then you're going to make delta the subject of the formula, and you find delta.
My delta is 5.528. I don't know others.
That sounds
Mine,
about.
sir, is actually 12,268.
No, remember when you increase your E, your delta should decrease.
Okay, thank you for the information.
Okay.
Sorry, sir. What did you say? When you increase what, the delta must increase?
Your excitation. That means your load angle is going to decrease. Okay.
Okay.
All right. What then? What do we calculate then? New current.
Yes.
It's like a new current and a power factor.
All right, so I2 is going to be E2 minus E1 over Z. So 1.15 times E2 is 1.23 times 1.15.
So how much did you get your E as?
1.383.
Okay.
Yeah, make it 4. Angle 5.528 minus, sorry, V1 minus 1 angle 0 divided by 0.225 angle 78 now. Okay, let's see. 1.384 angle. Oh shit, man. All right, I get the current to be 1.8.
1.563. Angle of minus 59.
Minus 59.
Angle.
How can you get a different answer than me?
I don't know because,
I also got 1.8.
Yeah.
okay, sharp.
Remember, it's 1.384 angle 5.52
Yes.
minus 1.
Sharp, which means it's me. I didn't punch the calculator very well, maybe.
Okay.
Minus 59.
Yeah.
What is the answer again?
1.779 angle minus 59.3.
Okay.
What do you say? Can you push the paper up because we don't see the bottom part of the paper?
Ah.
Okay, and then what do you have to calculate next?
Sir, it's because of your Z is 0.255 or 0.225.
That's what you said last.
What is that? It's 0.255. Sharp.
Okay.
Maybe it's me.
Yeah, the answer should be 1.57.
Impedance is
Yes, that is 0.255.
0.255.
Answer should be 1.57.
5.5 again.
Yeah.
It's 5.5.
255.
Yeah.
Then
It's 255. That is why I got 1.563.
Okay. I'm dyslexic tonight. 1.53.
563 angle minus 59.17 or 2.
Okay. And then what do we calculate next?
Power factor.
All right, the power factor is the cosine of 59.
It's 0.512 lagging.
0.512.
512 lagging.
Okay, good.
Okay, the next question. Maximum developed power.
All right, P developed maximum is going to be E over Z, E cos beta minus V cos 2 beta. Because for maximum power, delta is going to be equal to beta.
Sir, can I ask something?
Mm.
When we go through your notes, ne, we got that you have the formula that says E squared over ZS cos beta minus VE over ZS. We don't have cos beta 2 of beta. I don't know why. So is that wrong?
Yeah, that's wrong.
Okay, thank you very
It must be
much.
2 beta because remember for P-max, we say that beta must be equal to delta.
Yes.
Yeah.
I don't know if I studied one of your notes correctly or not, but I remember you said that at maximum power, my R tends to be 0 and
No,
my
no.
beta
That
is
is
equal
for
to
us.
90.
Yeah, so that becomes 90. But that falls away.
Yes.
No, that's for a large machine. Remember that.
Oh, okay. So
Yeah,
how do we know that the
yeah, we
machine
are
is
given an
large?
R plus. So then
Oh,
we
okay.
can't use that formula.
Yes.
Then you use long one.
Thank you,
Oh,
sir.
okay.
Right, thanks for clarity there.
Okay.
Sorry, sir.
Thank
What
you,
did you
sir.
just say on that?
What did I say? I said, shit, I can't remember.
Maximum power.
Too long time ago. What was the question again?
Yeah, she was
The
like,
question, maximum developed power.
Yeah,
the
then
beta
your
tends-
Like,
load angle becomes equal to your beta.
okay, then I remember they asked
Oh,
on the
that
other
one
one
was
that,
about R. She asked what when R becomes 0. Yeah, it's given, so you must use the long formula.
Yes.
So only if you are only
Sir.
given Z is equal to 0 plus J5, say, then you're going to use
yeah.
P developed as EV over X cos beta, or sin beta, sorry. But only for a large machine.
All right, sir. Thanks.
Next question.
Are you all fine with the clarity, guys?
On this one, we are fine.
Okay.
I just want to ask something.
Yeah.
There's on the notes there, there's certain notes about synchronized power.
Yeah.
Can we synchronize torque as well?
Yes, that's the next part of the question.
Okay. Una, you can proceed with the question.
Una? Yeah.
No, I'm done with the question. I get we have a study group, so they didn't understand me when I was explaining this. So I wanted them to say yes, we
All right, but
understand.
let's say we have to calculate the synchronizing power and torque for this machine.
Yeah.
P synchronizing is?
It is M pi over 180.
Eh?
M.
No, that is delta P. P.
Delta
D delta.
E
dP
V
delta.
over ZS.
Yeah. So that becomes delta EV over Z
Yes.
sine delta, sine beta, what? Sine delta. All right. Now delta is
So
equal
it's
to
sine,
3 pi over 1
isn't
8.
it, Mr. Leroux?
Huh?
Isn't it supposed to be sine beta plus delta because we have v times
Can you
e?
see it now?
Yes. Yes. Yeah.
Okay. So we've got a 6 pole, so that's 3 pi over 180. And how much is that?
It's 0,052.
Yes. 0,0524. Okay, doesn't matter. All right, now we can calculate the power. That is then 0,0526 times E was 1,203 times 1 divided by 0,255 sine of 78,7 plus 5, yeah, 8, and 6.
Sir, can I ask you again something?
Yeah.
When we move forward with this answer, do we still use the E that we got
The second
the
time.
increase,
Yeah,
the
normally,
second one?
it depends on the question.
Because I feel like the question is a continuation of that
It
increase in
says
15%.
Okay.
it says show that. Hey man. Say.
Yeah. All right. If you want that, then we can say, all right. It depends on how the question states, what it states, say in the first case or in the second case.
Oh, so
You
you're
did
going to
not
specify.
mention.
No, I'll specify it specifically.
Oh, okay, fair enough.
Hey, stop laughing. You're screwing around with your earmark. Times and then 78.6 times. Okay, I get 0.247. Make it 0.247. And the synchronizing torque is PS over omega. So that'll be 0.247 over 2 pi ns is 1,000 divided by 60, 16,66. Yeah, man.
So where did you get the 16,66?
That is 1,000 divided by 50. That's small ns.
Yeah.
Okay.
That is going low. Okay. And then you can convert it to actual value times S. And basically all the questions follow the same procedure.
Sir,
Hmm.
the last question.
Yeah.
By using a load diagram, compare your answers. Can you do that?
No,
Why?
it's a trick question.
Please, you.
Okay, let's say there you've got your V and your power factor 36.87 lagging. And then you're going to get IAZ, V and E. Now, the power increased, né? So, perpendicular to IAZ is 1 per unit power. And what did we calculate the power was? All right, let's say it was a certain value. That will be 1.x per unit. Now, E is now going to move up to there. The same E. And that is your new IAZ. E, 2. And this angle here, I don't know, forget about it. So that's your new position of your current. No, wait a second. Aye, Laru. This is if P increases, but only E increased, so no. Let me see. I 1.533. So P develop is E I cos of the angle between E and I. So that will be 1.384 times 1.533, and cos of the angle between E and V.
So can I interrupt you, sir?
Yeah.
There are people asking to enter the group
Tell them we must
on
come
WhatsApp.
earlier. All right, so that means it was 5 plus 59 minus 59, so that's more or less 54.
Do you think I want otherwise?
Just calculate that quickly.
$1.191.
Right, so now in this one, this was 1 per unit. And then 1.2, let's say whatever it will be there. 1.2. So E will just go up to there. And that is your new current. Okay.
Hey, that's a tricky one, sir. You shouldn't ask it on our test or exam.
Why not? You can do it most now.
Mm.
No, you can't.
No.
You can't.
Well,
That one
practice it
needs
now.
us
Smelling
to be
question.
in class.
Practice it now.
Yes, sir. Okay, can you repeat it again?
All right.
Repeat it again.
First of all, that was your original induced EMF, no? So that was IA1, V and E. Now remember, perpendicular to IAZ is your power. So this is 1 per unit power. So now we increase it by 1.19, say 1.2. So now that becomes,
Oh, sir, you are too quick.
ah,
You're
come on,
moving
man.
too fast.
You are too slow.
I know, sir. Please meet me halfway.
All right, so now what you do is you increase the power from 1 per unit to 1.2 per unit.
1 per unit.
So you take this value,
So are we increasing power or are we increasing induced EMF, or
power, the
obviously
induced.
it's going to increase? Okay.
All right, no, sorry, if in the first case, no, your power is going to increase. So now E is going to be the same radius as always, and that will be the new point. So that will be E2 position. Okay. Now, if they say the power remains the same, then you've got V and I and E. Ne? So, can you remember what we said?
Okay.
If we increase E, that value, then it will go down there and our load angle will decrease. And that will be the new power.
Sir,
The power is the same. This
you
is
are fast. Sir, for this one you are fast. The one of power remains the same. Yeah.
Yeah, because the power is there. That is 1 per unit. But we increased E by 15%. So that becomes longer. And now for the same power, it will decrease downwards until it touches 1 per unit power. So you can see your load angle is decreased. Remember, from 8 is to 5.
So can you do that one? Draw it again. This one of power remains the same.
This one.
Yeah.
Okay. There we've got V and E and IA. Right, 1 per unit is perpendicular through that point there. Now we increase E. What's going to happen? It's going to go down until it touches 1 per unit again. And therefore, our load angle will decrease. And this is the new IAZ.
You are too fast.
No, man, you're too slow. Just remember what I've done. I've increased E by 15%. Nah? That is that 1.384. Now it must go back until it reaches E 1 per unit again, because the power remains the same.
Okay.
And then that point to V is your new IA2Z. Okay.
I'm still waiting.
Huh? Waiting for
Yes,
what?
okay. Okay.
Right. So what now? Now you can check basically all the problems is basically the same as this.
The same.
Number 4.
Sir,
Hmm.
so the increase of that EMF, it's going to affect what? IAZ only.
Actually, it's only if, yeah, well, delta will change because remember, I said in the beginning, if we look at the stator there, and that is a rotor. Now, let's say the excitation is the rubber band that takes this rotor with it. So if we make E smaller, this rubber band is going to be becoming weaker, and therefore delta is going to increase. But if we make it stronger, if we increase E, then delta is going to decrease. Because now this is becoming stiffer with a more increasing. Do you see that?
I do.
Hmm.
I'm still trying to understand it though.
Let's say the electromagnetic field, we say that's equal to a rubber band.
Okay.
Now, if we make the field stronger, that means your rubber band is going to become stiffer,
Yeah.
and therefore your load angle will increase or decrease. What did I say? Stiffer, no? Now, therefore
Yeah.
your load angle will become smaller. All right.
Okay.
So say, with what you have just said now, is it safe to say that for me to have a maximum output power or power for a maximum E,
Yeah.
I need current needs to be my angle for my current and my angle for E needs to be as small as possible. The angle between my E and my V.
No. For maximum, E is going to be at an angle of beta.
Okay.
Because what happens is there's your normal E, and here is a maximum value for.
Sir, could you please shift the paper,
Oh,
sir?
yeah, okay.
Because we can't see.
There is, if R tends to 0, then it will be 90 degrees. But if it's less, then it's 87. So that same length will be there. There's now E maximum, and here's your E normal. And then your current is going to be somewhere there. Okay.
Okay.
All right, you see question 4 is basically the same.
Sir,
Mm.
can you do a 4.2 going downward, please?
Okay, so that is just a way of specifying what formula you have to use. In terms of load angle and the impedance angle. So then you're going to say E over Z. E cos beta minus V cos beta minus delta, if it's an alternator. And here in this case, you're going to say P2 is equal to 1.1 P1. And that will again be if the steam input is increased. So E is going to be the same. Z E cos beta minus V cos beta minus delta. So now you're going to determine what is your new delta. That is basically what we've done in the previous problem, except for we increased E. So let's say this was 0.8 original times 1.1. Then your new P will be 0.88. And then you just have to calculate the new load angle. And then we determine IA will be E2 or E minus E delta 2 minus V over Z. Okay.
What's that? Are you answering question 4?
Basically, yeah. Because it says there P2 is increased, the power is increased to 1.1 P1.
Yes.
And so that will be, let's say, for instance, what was 0.8 times 1.1 gives you that. And now the only thing that
Yes.
can change is delta. So you have to calculate the new delta,
Yes.
just like in the previous example.
Yeah, we got that one. I wanted you to go to 4.2, ne?
That's
Where it
4.2.
says, that one is 4.3, Mus.
Okay, the developed power in terms of the load angle and impedance angle.
Yes, we got that. And the maximum current.
Yeah,
Can you talk about that one?
the maximum
Maximum
current,
current. It's,
Imax, is going to be Emax, E at an angle of, let's say, 87 minus V angle 0 over Z. Because your maximum current
shift your page. We don't see.
now,
We don't see.
nothing.
Say you put it far from the your camera. We see the corner of the drawing of maximum and minimum.
Let me just, there.
Yes,
Okay.
again. A little bit more, sure.
Now, this E will be that value there.
So in this question, which means at maximum, the beta that you have there
Will be delta.
is the one that you're going to use there.
Yeah.
So your beta is equals to a load angle.
Yes, delta is equal to beta.
Okay.
Then you will get your maximum power.
Okay. So when they talk about draw appropriate phasor diagram, are they talking about because of its lagging? We draw that one of lagging.
Yeah. Basically, you're going to draw this one. Because this is for the first
We are
condition
joking.
where it's full load. And then what is the current that we're going to get? And that will be that one. And that will be phi. That angle that you're going to get here will be at an angle of phi. That is then what you have to draw.
Okay, sir. And then 4.4.
What does it say again?
Elucidate by means of a phasor diagrams what would happen to a single alternator if the load at the same power factor is increased.
Mm. So
Mm.
that means we will have that, and that is the power factor. Can you see? Oh, come on.
Yes.
Okay, and therefore we will have IARAIAXS, and that will be our load angle. Nee, Kas, jy kan nou nie hier kom staan. Okay, now that was IA1. Now at the same power factor, it means this will become bigger now. IA2. So what's going to happen is this going to increase, and that is going to increase. So what do they ask? Kati, you can elucidate.
They say elucidate by means of a phasor diagrams. What would happen to a single alternator
All
if
right.
the load at the same power factor?
You're going to say E is increased and your load angle is increased. And therefore your power will also increase. That is my cat that is playing around. All right. So E is going to increase. Delta is going to increase and P is going to increase. Does that make sense? Don't sigh like that. It's not so bad.
Another question. 4.5. Expound by means of a phasor diagram. What would happen to an alternator connected to an infinity bus if the steam admission to the machine is doubled, the excitation remaining
The same.
constant?
So if the steam is increased, then let's say
Sir, sorry to interrupt. Can you please move the paper up? Yes.
All right, so
thank you.
What did they say? That's V and that's E. If the power input, the steam input changes to, so that the load angle doubles. Just read the question again.
Expound by means of a phasor diagram. What would happen to an alternator connected to an infinity bus if the steam admission to the machine is doubled?
Yeah.
The excitation remaining constant.
So there again is 1 per unit power, and that is delta 1. Now, until delta becomes delta twice the angle, because that's what's going to happen if you increase the power to twice. So then you can say, all right, it's going to move to a new position per unit power. No, that's a bit stupid. It's not there. It should be less. You see, you have to draw to a certain scale.
Draw it somewhere else.
Now this is gonna increase like that until it cuts that power, wherever that may be. Shit.
Is that all?
Yeah.
Okay.
If the load angle doubles, your power is going to double. Because E is equal to, P is EV over X sine delta. So if delta doubles, then P will double. Okay.
Okay, sir.
Huh. Any more questions?
Question number 6.
Okay, what does it say?
A 2.2. You need a new page?
Yeah, it's fine. I'll write down here.
Say 2.2 kV star synchronous motor XS is equals to 1.8 ohm per phase.
Hmm.
Taking 100 A, it is a current
Yeah.
at a lagging power factor of 0.8.
Mm-hmm.
Is connected to an alternator.
Yeah.
Your XS is equals to 2.5 ohm per
Mm-hmm.
phase through a transmission line ZL.
Is?
ZL, Z,
Yeah.
not X, Z, which is 0.2 plus J 1.5
Okay.
ohm per phase. Compute.
All right. So you've got a, yeah. Now you must determine the power and the current flowing and what.
Yeah, we want to help us with the answers.
Oh, come on, man.
I'll say, hey.
Really, you guys, you must learn to help yourself.
Hey, we tried. We want to check if we are correct.
I don't believe that one.
Oh, but who?
All right. So that was 1.8. 0.2 plus J. What was it?
I told you must have a new page. You see now.
I don't have too many more pages yet. And then what was the alternator?
Alternator is 2.5.
2.5.
The
Okay.
motor is 1.8.
Right. So here's the terminal voltage, which is.
Sir, can you take your page downwards, Nyana? We can see, sure. So at least
127. The phase voltage of 2,200. And this current here is 100 amps, no?
yeah.
Minus 36,87. So V or E of the motor is going to be 1270 minus 100 angle minus 36,87 times 1.8 angle 90. Okay.
Yes, sir.
Then we're going to calculate E of the alternator. That'll be 1270 plus 100 angle minus 36,87 times 2.7 plus J 1.5. Because now you've got this volt drop here and you add that volt drop to get to E.
Okay.
So obviously you didn't come that far.
Sir,
Hmm.
I think we made a mistake there at EA. It's supposed to be for the ZL and the XS. The sum of should be 0,2 plus J 1,5 plus 1,8 J instead of
Oh, yeah.
it.
Yeah, you're right. It's not 2.5, it's 2.5x now.
Yes.
So that'll be, damn it, 0,2 plus J. Oh,
So it's actually 3,3.
no, 1,5
Oh yeah,
plus
yeah, no.
2.5.
Yeah, it's 2.5. Yeah, it's fine, sir.
Mm.
Sir, the next question, it's power transferred. I
Yeah.
think for both of them, alternating this, because it's like you repeated the same question for 6.2 and 6.3.
Okay. Let me just check something here. Just remember, I've got lots and lots of tricks up my sleeve, so it doesn't help if you don't know the work. And again, like I said, there's no trick, there's only a lack of knowledge. You agree?
Yes, I agree.
All right. Here is basically the same problem. So there you can see E for the generator and E for the alternator. Now, the big thing is the power transfer. That'll be EFG, okay, for the alternator and for the motor, plus all of the X's. Now, the only big difference here is going to be, all right, you've got your different angles between the two now. This one will be a certain angle and that one will be a certain angle. And this delta here is the sum of those two. And instead of the one transmission line, it's now going to be 0.2 plus J, 1.5 or whatever, instead of just 1.5. So you're going to get the little angle there. And then you get the power transfer. You can say that it is, in your case, EA, EM over Z total, or Z of the transmission line plus X of the alternator plus X of the motor, sine delta. Okay, but don't worry, I won't ask you one with that. I'll just give you something similar to this. If I ask that.
Okay, sir. What is the name of that book?
Oh, you won't get it.
Now I will download it. I will get it.
Please, if you get it downloaded, let me know. I want them download as well.
Okay, yeah. What is the
Because
author
that's
then?
By who?
P.S. Bumra.
Who's the author? Come again?
P.H.
P.S.
P.S. Bumra.
Bimbra.
If you can get that, I'll be very pleased because my book is falling apart. All the pages are
Alright,
coming
yeah.
loose.
Oh, thanks.
Okay, sir.
Mm.
Question number 7.
What does it say?
A synchronous alternator
Yeah.
has an induced EMF of 1.2 per unit,
Mm.
synchronous reactance of 0.2 per unit,
Yeah.
and is delivering power of 0.7 per unit.
Yeah.
If the prime mover's output
Mm.
is increased by 2%,
Yeah.
decide the percentage change in P and Q.
Okay. That's all that's given. No power factor, nothing.
Yes.
Yes, sir.
Hmm. All right, so P is EV over X sine delta. So now we can calculate delta. Is XP over EV. So that is 1.2
Sir, we don't see. Can you take the page up? Okay.
0.7 divided by 1.2 times 1. Sine delta is equal to that. And therefore delta will be
Sir, fix your X. Your X is 0.2. It's like you wrote 1.1.
Can you see the new
1.2.
one? Can you see the 0.2 now?
No, X, not.
There, that one.
Yes, that one is 1. Yes.
Okay. How much is that?
6.719.
All right, the sign, the arc sign of that.
It's 6.719.
Oh, 6.719.
4.4.
What?
What is there is 1.2 by 0.7.
It's 0.2 by 0.7 over 1.2.
Oh.
Then the sign arc of that.
Okay. So the new delta will be now 1,02 times 6,7. What is that?
So where do you get 1.02?
The 2% increase.
So what's increased? They say if the prime mover's output is increased.
Yeah. So then your delta will
So
increase. Because the prime mover changes the the position of your rotor.
will I be wrong if I increase mechanical power, which is developed power?
No.
Or is the same method, like we'll get the same answer if ever you go for that one?
No, but I mean, if you increase the input power, the only thing that's going to increase is your load angle and your power.
Okay, sir.
So 1.02 times 6.7.
6.834.
Okay, so now your new P is going to be E, which is 1.2 times V1 over 1.2 times the sine of 6.834.
Yeah, so it's the same, because if ever you increase your P, you get the P developed too. You will have to get the load angle. Then I see we got the same load angle. Yeah. And this one of yours is the short one.
What do you mean the short one?
Because this one I go a long way for me to get that angle.
Okay. Sam, it must be difficult to be so dumb, huh?
Ish, please, Claire. Ish.
I can't sympathize with you. I don't know what it feels like to be like that.
Oh my God.
Oh, okay. You got it now. Did you get the same answer though?
Let me check. I want. They don't calculate, yo. Let me calculate it.
Oh, don't worry. If you differ, then we can
What is
discuss it and see.
Is 0.714. 0.714.
How did you do that?
I said 1.2 over 0.2. Sign off that.
Sign off?
Sign off 6.834.
Yep.
Actually, you wrote it there under the load angle.
Yeah.
That's the one that we wanted, Mus.
Yeah, but that's the new power now.
Hey, I'm saying the value for that one is 0.714.
Times the sine of 6.834.
You want the sign of 6 point something?
Yeah. You must multiply those
Okay, let
to
me.
get the new power.
No, sir, she's correct, sir.
Oh,
It's
okay.
0.714.
Okay.
Now you have to decide the percentage change in P and Q.
Okay, so first of all, you can calculate Q. Q is?
It's VE over Z.
Yeah, minus V squared over Z cos beta or cos delta.
Is that so? It's not VE over ZS cos load angle minus V squared over Z.
No, I don't think so.
Hmm? Say.
Oh, so. But okay, it doesn't matter. You calculate the new Q and the new Q here, and then the difference is P2 minus P1 over P1. Same, yeah, Q2 minus Q1 over Q1. Okay.
Say,
Yeah.
do you know why I'm saying that one is wrong? Because I get your R is 0, so your beta is 90.
Oh shit, what's going on? Oh, the time's up now.
Oh.
Oh.
Okay, so which means when we meet, we'll continue with that one here. Because
Yeah.
they change part.
Yeah.
Or we can start it again, sir. It will give you another 40 minutes.
Let's hope. Okay, can you see me now?
Hey, we see.
All right. Okay.
Say, are we continuing?
Yeah.
Okay, I'm saying why I'm saying that your formula is wrong is because it's your R is 0. So from the original formula, you must put 90 on beta, which is the side of V squared over ZS sin beta, which means you will have 1 there.
Woman.
So fix that formula, it's wrong.
She's right, sir.
Okay, it's fine. It's fine, sir.
It's going to be.
Yeah, it's got nothing. There's no beta in it, so let's look at Q is E over Z, E cos beta minus V cos beta plus delta, no? Okay, so that becomes cos of 90 is 0.
Sir,
Yeah, okay.
Oh, what's it?
EV over X sin delta. Yeah, man.
so are you saying our Q is equals to EI cos? It's not VI.
Yeah, it's V, sir. Instead
That is
of
in
It's not
developed
E.
power.
Oh, it's for developed power. Okay.
Yeah.
Mm.
And for the output power, it will be V.
Correct.
Okay, I didn't know that it applied there. Thank you for clarity.
Mm-hmm. But there's something that's not right here. There's something wrong. Cos of A plus B becomes cos A, cos B,
Same.
mine sin A, sin B.
But sir,
Yes.
before you can go there, isn't it that reactive power is E sine beta instead of cos? Because that is always going back to active power. You will calculate active power, not reactive power.
So that'll be cos beta, cos delta, sin beta, sin delta. Okay, that falls away. Minus sin
We can't see, sir.
There's something definitely not right.
What is wrong there is that cos beta, it was supposed to be sine, not cos.
Let me just check that.
Yeah, Warren is right.
Because of
From the original formula,
Yeah, Q
Yes,
is sine,
that's
sine beta.
sign.
Sine beta, yeah, the sine, not cos. Yeah, you are right, Warren, because he's going to a real power.
the reactive
Please
power.
fix, please, sir.
Let me just check here something.
That doesn't trust us anymore.
Say what?
You don't
say
trust
that
us anymore.
The formula which you're using there, because of the cos beta, is the formula for active power, not reactive power. Say. You were supposed to use sine beta minus V sine beta plus delta. Then formulate it from there.
Look here. The real and the imaginary parts of the equation. You get P is VE over sine, and Q is VE over. That's the
No,
output.
there's something wrong with that equation.
No, there's something wrong with your seeing this because I've been teaching this subject many years.
No, but from basic principles, what is P plus J sine J sine theta? If I'm saying I have P cos, P is a cos real power, but the sine side of it is an imaginary power, which is the reactive
Just look
power.
at this equation, how it is explained. It's VE cos delta minus J sine theta minus V squared over J XD. So if you take the Q value, then it becomes VE over XD E cos delta minus V.
So that one is the final formula after
manipulating. All right. Una? Are you good?
I'm copying it. Let me shoot it. I will derive it.
Good.
Okay, it's fine.
Okay. All right, but being that as it may, then you're going to use Q to determine Q1 and Q2. And that gives you exactly the same thing as P. So you're just going to... All right, wait a second. If you want to say Q is P sine delta. Yeah?
Yes, that's what we want.
So in other words, that will be 0.7 sine 6.7. And then P2, then you're going to use Q2 is 0.714 sine 6.834. And there you've got your P's and your Q's. You got?
Oh, thank you. I will go for the next, for that one, for that method, right?
But then you can soon see if you've got the same answer with that.
Yeah, I will check. Yeah, I will check the formula.
Okay. All right. Any more questions?
Okay, the next, question 8. You want the clarity? I don't know where. Okay. Question 8. I don't know if you already explained this. 800, sir.
Yeah.
If you already explained this, please don't kill me. 800 kVA alternator has an impedance of, and we can see, please bring your paper in the middle.
Yeah, let me first write, man.
Okay. Alternate has an impedance of 0.168 plus J 0.626 per unit.
Hmm?
It delivers full load at a lagging power factor of 0.8.
Okay.
If the prime mover's output is slowly increased,
Mhm.
analyze the maximum load angle and the output.
Okay, this will be 0.68 at an angle of 75 or something.
Say page in the middle.
What is the value of 0.168 plus 0.626?
Hmm?
What is the value there?
Value for what?
For
Comma
0.162 plus point, how much?
648.
All right, at an angle of
70. We can make it 75.
okay. So now, first of all, if we're going to calculate E,
We don't see.
what don't you see?
Sharp.
So that's going to be E. Right? Now, if beta becomes for maximum value, it will be E at an angle of 75. Because now delta must be equal to your impedance angle. And that will be your new IAZ. And your current will become leading. Okay. Just tell that guy to mute his. I don't want to hear all the family fights. Okay. Have you got that one?
I'm still putting it in my head.
So
sir,
say E angle delta is 1 angle 0 plus 1 angle minus 36,87 times 0.168 plus J 0.626. You get E1. And then E for maximum is going to be 1 plus 1 at an angle of 75. Yeah.
Sir,
So
I'm
now
getting
the
confused now, sir, ne? Because now you're saying that the power factor now is equals to the angle of the impedance.
No. The load angle. Delta.
But you wrote there.
There I wrote it.
Yeah, but there when you substituted for E maximum, you put for the angle of current, you put 75.
Oh, okay, yeah.
You were supposed to find what the current, I think.
Yeah, I'm supposed to find the current. So IA
yes
is gonna be. I'm getting old. E and 7 and 5.
You are old.
But before we write test, please give us the memo so that we can check the memo if it's correct and then.
Okay. Right, then you get your new E. IA.
Okay, sir. Load angle and
Now with
output.
this,
The
you're gonna
question
get.
it was saying, you get the angle, yes, the current. It was saying the load angle, which means your load angle is beta is equals to that. You answered that.
Yeah.
Then now, and the output current, we are going there. It's output.
Yeah.
It's output power, I think. Yes, they want output power. They say output.
Okay. So then
Yeah.
you say P out.
The maximum load angle
V
and the
times
output. Yeah.
IA cos phi. That's what it's gonna be. Okay.
Okay, sir. You are done with that one.
All right.
So the other question, question 12.
Mm-hmm.
Yeah.
What does it say?
Okay, it says a 11 kV
Mm-hmm.
three-phase alternator
Mm-hmm.
has ZS, which is equals to 0.4 plus J5 ohm per phase,
Oh,
and
yeah, that one
supplies
with 15 amp. It supplies
and
15 amp with
applies
zero power factor.
2000 amp
Oh, all right.
at the
Now,
unity power factor.
2000 amps at unity power factor. Yeah.
To an infinity bus.
All right. This
The
one.
citation.
First of all, we have to cover another part of the work there, the capability diagram of an alternator. That I'll do that next time with you.
Okay, I must leave this question. We'll see it
Yeah.
after that.
Yeah.
Okay,
next time.
Sharp, let me make it. I'm making it. Another
You can look in your
question.
book. It's under the loading capability, the capability diagram of an alternator.
Of alternate.
Yeah.
Say, okay, we will check it, but you must go through it with us, please.
Yeah. No, I'll
Okay,
do
another question.
Hmm?
Okay, another question. Question 14. It
Are you the
says
class captain or what?
a 1.5.
Are you the class captain?
No, let me read it.
Yeah.
A 1.5 mega VA. Oh, wait, sir, this one, ne? I think it's the same questions with, if guys, you can check, it's the same question with other questions there, because we didn't understand 14.4 and 14.5. I think it's the same. You can check it, guys. Say already explain it.
Yeah,
Question
it's
14.
the same.
Okay. So.
Yeah, that one is the same. I did it already.
Okay, thank you very much. Not sure. Question, I don't know. Question 20. The voltage regulation. Let's go. Let me give you the data there. Question 20 of 7 marks.
Yeah.
10 kVA 230 volts, star,
Mhm.
synchronous impedance of 0.3 plus J10 ohm per phase,
Yeah.
and a field resistance of 4.5 ohm. The excitation current is 10 amp for a lagging power factor of 0.8. You are far away, ne? Field resistance
Yeah.
4.5. 4.5
Okay.
ohm.
Now
The
the other
excitation current is 10.
I is 10.
Excitation current is 10 amp.
Okay.
Lagging power factor.
Yeah.
Resume the efficiency and into a voltage regulation.
Yeah. The efficiency. Just remember that will be the output. Normally we say the input, but we don't include the field losses. Now for that case, we just say plus your field loss. Then you get your efficiency. Voltage regulation is still going to be E is equal to V angle 0 plus IAZS, beta plus or minus phi. And then the voltage regulation is E minus V over V.
So we got 163.348%. Is that giving sense?
163.
Yes, percent.
Yo, what was E?
Yes.
It's 30 angle 0 plus, what was the full load current?
Sir,
Ah,
you don't change that thing against the line. It's not the line, it's the stamos. We don't work with phase. We don't change.
yeah, you work per phase.
We changed that one we got 132.7. Sir, voltage 132. 132.
Well, okay, yeah, all right, 132, yeah. Angle 0.
132.79. Angle 0 plus 25.1
Okay,
times
25.1. Angle minus 36.
times that impedance, right?
Yeah.
So it give me a 349.70 angle of 34.1.
Okay.
Yes. So now you take that one minus 132 over 132.
Yeah.
Yeah.
Yeah, that's a big one. Okay, I'll check it
So
and then I'll work it out myself and see where is the mistake.
okay, let me make it. This is the second question that you're going to help us. And then let me check another one. I think we are done. Alternate, I will do a generator next time.
Motor, you mean?
Sir?
Motor.
We are motor. Now we are done with generator. Those are all the questions that we had. So
Okay, that's fine.
yes. Any question, guys?
No, I think the questions are now clarified.
Okay, sir. See.
Sir,
Yeah.
So
Thank you very much, sir.
sir,
Pleasure.
And another class captain.
sir,
say
Yeah.
bye. Good night.
sir, I do have one question.
Huh?
Okay.
I do have one question.
Yes.
Do we always have to use the per units if not stated, or you can calculate the normal way?
You know, the per unit is much shorter.
But what if I like the other way?
No, it's not
the
if you
per
like. I will tell you which one to use. If I don't say anything and the impedance is given per unit, then you must do it in per unit.
Okay.
Or if I give everything in real values, and then I say use per unit to solve, then you must change everything to per unit.
So if you give us the impedance in per unit, then every calculation has to be in per unit.
That's right.
Okay, thank you for the
Guys, always
Alright,
before you
yeah.
answer the question, check at the end of your questions. You always put that thing there telling you what to do, because now you're going to just answer only to find out that you answered with actually he want per unit. Now you have to start over. It's what I saw one of the questions. So always check below the question. That's the trick.
No,
I
sometimes
don't
I
know if
don't
you
say.
it's a trick. You did that to me, Mus.
Yeah, but
then
I
when you
say,
are doing something,
if
then the thing
the big thing to look for is your impedance in per unit.
Yes. So,
And then
sir,
I can
next time when we
specify
meet,
other words.
which chapter are we going to do when we meet again?
I'll do that part of the compatible load characteristics of the alternator, and then we can do motors. Okay, actually,
You have two.
Motors, you can look at it because it will be the same as what we've done so far. The only
Sir,
difference.
yes, we'll do it. Then you come and go through so that we can check if we did right or wrong.
Okay. All right.
Oh, now what are you
But
saying,
from,
Richard?
yeah,
You're saying what about motors? You
sir,
saying you will do,
sir,
or you saying that we will
Agri
go
said he's
through?
going to do 2 questions. He's going to explain that when we meet again. Do you get me, Warren?
The capability
Then
graph.
after we do synchronous motor.
No, listen. When we meet, we not doing questions. We asking if we're going to do the capability, where he will explain.
Yeah. I'm
Not
going to do that.
the problem.
And this question 20, I will check. And then we can do motor.
Yes.
And when is the next class again?
When? Next Monday or Wednesday?
Next Wednesday or this one?
Let it be Wednesday.
This Wednesday.
Which one?
Yeah,
Yes.
Wednesday.
This one.
Yeah, this Wednesday.
When are we writing?
Shit, I don't know.
Hey, what's that?
Machines in parallel, are we jumping it since is the
Pardon?
machines in parallel? We just jumping it, or you assume that we know it.
Yeah. No, I'll find out from the HOD and then I'll let you know. Okay.
So you said the first test will be from which chapter up to what chapter?
To chapter 3.
Chapter 3.
Yeah, synchronous. And then the next one will be
4 to 5.
salient pole and design.
Yeah.
That is too much for now.
No, man, you've covered all the work up till now.
So the test, it will be an online test, or we have to come to school? Social distancing, what's the story?
Yeah, if I do it online, you're going to sit in a group and then help each other and then you all fail.
No, sir, we stay far from each other.
Yes, sir, we stay far from each other. Some of us, I live in KZN for one. So please kindly tell us in advance so that I can know when to make travel arrangements.
No, I think I'll try and I'm waiting for them to upload my stuff on Blackboard. And then I will,
Okay.
I will give you the test on Blackboard.
Better.
Oh, okay. Good. Yeah, it's
Is
better.
it gonna be a multiple choice?
No,
How are we gonna write those formulas on Blackboard? Sir?
you'll probably
And
have to write it down on a page and scan it and send it to me.
Okay.
Okay.
That's very good.
That's
On
better.
your email.
Yeah,
That's very nice.
Okay.
That's very nice.
is it?
Yes.
I
So-
must
so
ask
what
something
do you-
that's
what-
not in the book, ne?
So
again?
sir, what if you get it late?
What if you?
What if
Send
like
it
you get
late.
it late? Maybe like when I was studying it, I had a problem with an internet. Then when it happens that you get it late,
That's a
you will
problem.
have like a time.
No, there will be a specific time that the questions open, and then after a certain time, it will close. 1.5 hours.
Eish.
All right.
Sir,
We shall
Okay.
see.
sir,
Mm.
or you can maybe have a chat with Dr. Van Rensburg. He had a way of a submission on every page.
Yeah, okay. All right, I'll find it out from him. Let's see if I can do it that way.
All right.
Okay, have a nice night.
Bye.
Good night, sir.
Okay, bye-bye.
Sorry, sir.
Bye.
Mm.
Mr. Leroux.
Yeah,
I just want to ask a question. You mentioned the notes. What did you mean by that, the notes?
what note?
Well, everyone was talking about that's in the notes. I'm not sure what they're referring to. I'm not sure if they're referring to the questions that you sent that we printed out, or if there were some notes that were given.
No, I never gave any notes. I don't know what they talk about it.
Is it? Okay. All
Okay.
right, then, sir. Enjoy your evening.
Okay.
Sir,
Yeah.
the book.
Oh, shit. Haven't you got it yet?
No?
Oh, those people are terrible. I'll phone her tonight and see what she says.
Okay, sir.
Okay.
Thank you very much.
Pleasure. See you guys.
You
Wednesday
can
night,
now have
6
a
o'clock.
good night.
Okay. Bye.
Bye.